In example 1, we're asked to determine the solution set for the inequality 2x plus 3y is less than 6. So essentially we're looking for all of the x and y points that when we plug those x and y values into our function 2x plus 3y, we get something less than 6. Now in the introduction we saw that when we that this line 2x plus 3y equals 6 divides the plane into two parts. On one side, if we pick a point from one side of the plane and put it into our function 2x plus 3y, we get something greater than 6. And then if we pick a point from the other side of the half plane and put the x and y values into 2x plus 3y, we get something less than 6. So basically, we just need to we're going to solve this graphically, right? We can't list any individual point or any finite set of points. We're going to have an infinite set of points that satisfy this inequality, and it's going to be one or the other half planes that this line divides the Cartesian coordinate plane into. All right, so we just now need to figure out which is the correct side. Which side gives us values, or which xy coordinates give us, when we plug them into this function, they give us values that are less than 6. Now, we already really figured this out in the introduction, but if you don't know, you just need to test a point, and it can be any point. And oftentimes, the best test point is 0, 0, just because it's really easy to evaluate 0, 0. So if I pick a test point, 0, 0, and I put it into this inequality, I get 2 times 0 plus 3 times 0 is less than 6. And we just have to ask ourselves, is this true? Is this true? Okay, well, 0, this is basically 0 on the left-hand side, because 0 times 2 plus 0 times 3, that's all 0. 0 is in fact, less than 6, so yes, this is true. This is true. So in order to indicate the solution set for this, this inequality, we're going to shade that side, because we tested this point and we found that that point works, which means that any point on this side of the line will work. And so to show our solution set, we're going to show it graphically by graphing the line and then shading the correct portion of the plane. Okay, so I'm just going to draw lines here for shading. Okay, so that's my shading. So that's indicating that that this half of the plane contains the points that satisfy this inequality, that make this inequality true. Okay, so we're going to shade that part. Now, the other thing you might notice is that I drew a dashed line. And the reason I drew a dashed line is because the points on the line are the points that that cause this to be equal. 2x plus 3y equals 6. But we only are concerned about the points that are less than 6. So the points on the line are not included in the solution set. So that's why I use a dashed line. So the rule is to use a dashed line. Oops. Use a dashed line when the points on the line do not satisfy the inequality, right? So that the points on the line do not satisfy the inequality. Okay, so since any point I pick on the line itself, because I graphed the line 2x plus 3y equals 6, those are the points that, in which 2x plus 3y equals 6. But I don't want those points. I want only the points that are less than 6. Okay, so that's why the line is dashed. All right, I'll meet you in the next video for the next example.